Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. And I wanted to, I guess clarify is the wrong word, but rather I wanted to fill in something that I failed to mention when we were talking about on the sparse entity system. I made the whole analogy, but I never came out and said it. And Chris Hecker emailed me this morning, I think, mentioning that he had watched it, and I never said the thing that I should have said about it. And I went back and looked, and he's totally right. I never said it. I basically, I drew a diagram. I made an analogy and then never actually said what the analogy was actually about, which is not very useful to anybody. So let me go ahead and finish this off here. If you remember when we were talking about entity systems, I mentioned this one here called Act React by Looking Glass, which is the first time I'd ever heard of anyone doing a system of this form. And what I was explaining about that was that it was equivalent, or not really equivalent, but it was analogous to sort of the way we had been thinking about SIMD before, where there's an array of structures method of thinking about entities, and there's a structure of arrays method of thinking about entities. And previously, mostly people were thinking about array of structure style ways of working with entities, and they had sort of changed it into SOA by doing this. And what I never actually mentioned is why you would want to do that. I pointed out the drawback to it, one of the things that I don't like about it, which is that anytime I want to do something that talks about multiple aspects of an entity, I have to go grab that information from lots of different tables, right? And you can see why that might be a concern. But that is not actually the reason why you do it, obviously. That's strictly a downside. So if that was the only thing, you wouldn't ever do this. The reason you do this is because you can get a win from grouping all of the properties together, just the same as you do when you're talking about structure of arrays versus array of structures, right? So the form that this takes is, let's say, using the example that was here where I've got burnables, if I've just got the burning state, what the amount of fire is on this guy, if I've got that set on each individual entity, well, now, if my fire system has a propagation pattern to it, like when I have fire and I propagate those to things that are nearby me or something like this, that may be a very specific simulation algorithm that wants to store things in a finite mesh grid thing to speed up how it's computed, and maybe it's got all this stuff. What you might want to do is have that be its own separate sim where everything is organized for optimally processing fire, right? And that way you can sort of optimize that path and make it very fast without having to have this whole gather step where you bring in all of those things, right? And so what you kind of get here is this idea of, well, sometimes maybe it's faster that everything's with the entity, sometimes maybe it's faster that everything's with the property, right? And that's not, I don't really think that's a super useful way to break things down, to be honest. But then again, I'm not a game play coder kind of person, so, my opinion on it is not super relevant, I don't think. There might be really good reasons to do it, but it's not probably how I would approach the problem, because I don't see that as being the most common case for how you would want to optimize things, because it just seems like it's not going to come up that often. But that may not be true. At the very least, what I can say about it is that if you find yourself in that scenario where you've got a certain set of properties that want very specific optimized patterns to them, then you can kind of hopefully you can clearly see why this might be a useful way of doing that. And you don't have to do it for everything. You could still have some things that are AOS, right? You could still have entity structs or classes or whatever else you want. And then you can just have this side thing that's like, okay, because fire or water or something is this special property that's much more difficult to simulate, and we need this sort of separate system for it, we keep that out in its own thing that's optimized very specifically, and we do lookups into it on the occasions when the entities themselves need to grab a particular thing out of it. But otherwise, it's always kind of its own thing. You can see why having that architectural option might be a valid way to, might be a viable thing for you to want to do. So hopefully that gives a little bit better, because I basically skipped that part. And yeah, I drew this out, but then I never really said what it was. So hopefully that's a little more clear. All right. That was all I wanted to mention. We are right in the middle of changing the entity system over, so there's not much to talk about right now. We're just finishing what we said we were going to do yesterday. and did a lot of, but not all of, right? So we did, as much as we could in an hour, but we still have more to go to finish converting everything over. And so if you ran the game right now, you would be in a very sorry state, because it doesn't actually have a way to, well, actually, I guess I don't know if that's true or not. I don't remember exactly where we got to, because we did actually move everything over to loans. I think what would probably happen right now is that when you call an entity, it doesn't ever actually go pack that entity into a chunk anywhere. So basically what happens is we're building these entities, and then they just would get thrown away. They wouldn't actually happen. So what we need to do is actually go finish all that work. We need to do that in end entity, and we also need to do that in the code for sim region. So those two code paths want to kind of coalesce, and that's exactly what I think we will be doing today in order to get things back to a working state with the new design. Today is day 279, so if you're following along with the source code, go ahead and load 278, and here we go. All right. So the part that I was talking about just now when I said, it would get to the point where it created the entity and throw it away, that's this code right here, and you can see that I've got a not implemented in it. So what's going to happen is we're going to do this begin low entity. The entity will get built out, and this is just at creation time. It's at like world creation time. We build the low entity, we set all the parameters for it, but then we immediately just throw it away, right? And what do I mean by throw it away? Well, what I mean by throw it away is we're constructing it into a temporary buffer here, this right here. We're constructing into that buffer, and what we need to do if we actually want to save it is now we have to move it over into permanent storage somewhere, into the world where it's getting tracked. Okay. And by the exact same token, if we go back to our Handmade sim region, that same process we have not implemented over here either, right? So if we come back over to this piece of code where we've got not move entity, where is endsim? Endsim. Here it is. When we go back over here, I've if-zeroed it out, but this is the exact same code. This endsim has to track what's happening here as well. Now, what I think I'm going to do, because it's a fresh day and a fresh start, and it's like the coding has been rolling all day and is ready to keep on rolling, I'm just going to say, let's go for gusto. Let's just forget it. Let's not even do baby steps here. Let's just get the sim stuff working the way that it should actually work. And so what's going to happen here, if you look at the way this code is structured, inside the begin sim, when I'm pulling this data out of the chunks, you can kind of see how I'm doing that here, right? I loop over the chunks that are like whatever the sort of block of chunks that would be related to the place that I want to sim, and I'm calling get world chunk on them, and then I'm loading in all of the entities that pertains to, right? Now, what I want to do here is, again, this sim is meant to be a stream in, stream out system. So the goal here is to pull everything out of the world. And I'm not actually even going to leave it in there, meaning it's not like I leave the backing store in place. I'm going to obliterate the backing store. So I like pull that stuff out, and then it's gone. And then I sim it, right? And then I put it back in. That's the current way that I'm conceptualizing this working. Again, I said it's a crazy system. I don't pretend that it's not on the fringe. It is, but that's the way we roll here at Handmade Hero. So just, you best not step to it, bro, or something. So anyway, point being, in here we have the Handmade world code, and we sort of made a slight concession to this where we changed the world chunk to a world chunk star here in the chunk hash, and then we basically put in these things where we had like first block and whatever. And it occurs to me that this may actually be, again, one of those things where I'm not certain that I'm not certain we nailed it, I guess is my concern. What I think might be more appropriate is we might want to change where the pointer is. I think that may be a better place for the pointer, if that makes sense. And this, I'm sorry, that may be a bad place for the pointer, and this may be a better place for the pointer. And the reason that I say that is because, well, actually, before I even say that, because that may not be true, let me tell you what the problem is, instead of jumping to a solution which may not even work. The problem is we're going to go in here to the chunk hash, and the way that this is going to work is we're going to pull out all of the world entity blocks, and they're going to disappear, right? So they're just gone. and then we're going to put them back in later. So what we kind of want to do is pull things out of the hash entirely to a certain extent, I suppose, and then put them back in entirely, right? So, I don't know. Maybe this is still fine, because I guess we want to pull things out of the hash entirely, and the hash does have to have this, and then it's got to have the next pointer, so I don't know. Maybe that makes sense. I'm not sure. So let's just pretend that it does for a moment, and we'll go from there. Okay. So what if I was going to actually do it and leave it? Instead of me saying that that was going to be better when I don't really know what it would be, let's just do it the way that it was and leave it that way. Okay. So what I want to do here is I want to excise the world chunk that I'm talking about. So instead of me looking through these and saying get world chunk, like I want you to give me back the world chunk, what's the word I'm looking for? Like I want you to give me back the world chunk and keep it where it is, and I'm just iterating over it. I want to actually pull it out so it's gone, so it's not there anymore. And now that I'm thinking about this too, as I'm saying it, again, I'm leaning more towards that solution that I'm talking about before. So here's another sort of example of where this is where there's another thing that we might want to consider, right? And that is, if I want to leave the world chunk in place as a marker, that I then go and vaporize only later. And let me tell you a little bit about why I might want to do this. Now, I don't suspect that I do, but I'm just gonna tell you what is sort of in the back of my head with respect to that here on day 279, right? Oops. Okay, so what I'm thinking is I was sort of thinking about the concept of transactional memory here. And what transactional memory is it's a very, very simple concept that is dressed up by a very fancy term. And all it really means is if I want to do something multi-threaded, and I have a chunk of memory that I know that I'm going to operate on, right? So I've kind of got this thing where, I don't know what this is, but this is like my target. This is the thing that I'm actually operating on, okay? Then the standard multi-threading problem that I run into, if we didn't ever have to worry about threads colliding with each other, then we just run all the threads at the same time and we don't care, nothing, it doesn't matter, right? Everything works, it's great. But we obviously, when we talk about multi-threading, we always talk about these problems that we get where, we've got thread A here that's coming in to do something, and we've got thread B here that's coming in to do something as well, right? And so what we end up with is a situation where we do something like, oh, okay, I'm going to come in here and I'm going to do something to this target, right? My thread is going to do something to this target. And then later, thread B is going to come in here and they're going to try to do something to this target as well at a separate time, if this is T right here, right? And A is not going to finish until after B starts, right? So if we just allow these two threads to just run, then what we would get is some kind of probably corrupted state, because B is reading a partial update of A, like whatever got finished up to here, making some changes, and then A is completing not knowing that B read that data, and then B, when it's actually writing stuff out, is going to write out using part of what A updated, and you got this nasty kind of partial visibility. It could be even worse if they're doing reads and writes at the same time. B gets some of the A's data, A gets some of B's data, it's just bad, right? And so one thing that I was thinking about in terms of the streaming system was like, well, what we could do is have some sort of system where when you get something out of the world storage, you actually just mark it as to whether or not you were going to edit it or not, right? And if you're not editing it, you leave it in place as marked as something that you read from, and that anyone who's coming in who just also wants to read from it doesn't collide, right? And so the reason I was thinking about transactional memory is the way transactional memory works is all you do is you do the update, right, exactly as you would have on whatever. You basically do the thread as if you were going to do the thread normally, and everyone just operates as if they can, right, as if there is nothing stopping them. And then when they go to actually commit their changes, all of the changes they're going to make get buffered till the end and then get written out. And what happens is it's only those writes that are checked. And when that write is about to happen, when that block write's about to happen, it checks to see like some value in here, right? That you use as a key value that says, you know, it's basically just a, you know, an incrementing integer or whatever you want that basically says, has anyone touched this since I read it? So when A comes in here and grabs this value out, you know, and this value is set to 1 or something, right? B comes in here and it grabs this value, it's still set to 1, right? A then commits its changes, which sets this value to 2. B then goes and says, oh, I need to commit my changes. What is the change value? Oh, it's 2. I have stale data. It just restarts itself, right? It just goes, all right, let me start over. And so transactional memory is just something that allows everybody to run at the normal speed they're going to run at. And all they do is they just, if they find that when they go to commit their changes, somebody has come in and changed stuff before they were able to write out their changes, they just restart. And so I was thinking a little bit about that in terms of our system, because if we want to have multiple threads running that all update different parts of the world at the same time, I feel like probably what we're going to do is try to make them not overlap, but that's easier said than done sometimes. So one thing that I was thinking about is, well, if we have a system, you know, and the system is updating 2 people, and like one of them's updating here, and one of them's updating here, so they both have like an apron that looks like this, you know? I was wondering about potentially supporting the case where even though A is only updating this region, and B is only updating this region, they're each reading out of regions that are being updated by somebody else. And if we wanted to support the case where there's no locking, we don't prevent this case, we just let it happen, right? But what we do is when we go to commit the sim region changes out, we check to see whether any of the chunks that we read have been updated since then, and if they are, we abort and restart the sim, right? That, if we did that, would argue strongly for leaving the chunks in place, right? Because if we don't leave the chunks in place, we can never do this. Because when this went to update, it would find nothing was here. There was actually, all the data's gone. Because B sucked it all in, and you don't even know it's there. So if we don't have a higher level scheme somewhere that thinks about who is updating what where and make sure that they don't overlap, we would have this problem. And I don't really know what our best approach is for solving that, right? So it's something to think about. I suppose we could start with the simplest thing first and not really worry about this too much. But I just wanted to kind of give you what was in the back of my head and why I'm not really sure exactly how I want this process to occur. Thankfully, because it's a stream-in, stream-out system, it means that all of the entity code we write is isolated to the simulation part of things, which I really like. That's the part I think is cool about this system. And so that means we can change the decompress, compress step a lot without having to really change any code anymore. Like those 2 pieces are now completely separate from all of the entity code, and I love that. I think that's really great. But we still are going to have to figure out how they work eventually. So for right now, I guess I won't think about it too much because, like I said, I'm not sure what to do, and it's not something that is going to affect dramatically all of this other code we're going to write. So I think that's okay because this will be a fairly isolated piece that we can play with over time. So when we go and drop in that multi-threading, I can change it then, and that's a good thing, right? I think that's what we want. Because until we actually try doing multi-threaded entity updating, we won't really know probably what the exact right format should be for what we're going to do. And so I'm thinking that probably we want to keep that as a thing that we do when we try to multi-thread it. So I'm going to go in here and say when we do get world chunk, I'm going to say like something like remove world chunk. And then when we do this iteration, we do all the loading as we normally would. And then what we're going to do is we're going to take that world chunk and we're going to put it on the free list, essentially. So we're going to say like add chunk to free list, and that's going to presumably be on the world. So we'll just put those chunks back, we grab them off, and we throw them back to be used at some later date, basically. And then in here where we have the blocks, exact same thing. So instead of doing it this way, I'm going to pull those blocks off one by one and return those to the free store as well, right? And this is why I say that pointer is kind of inconvenient, because it makes this code harder to write. If this block was just a pointer, it's easy to just pull things off the block as we go. But if we don't, if we instead do it a slightly different way, where we've got this sort of the block is the first block in there, then it's kind of this annoying thing where I have to write that code a little bit differently. And that's why I wanted this to potentially have that be a pointer. But let's see, I'll see how annoying it is to actually do that. It's probably not too bad. So in here we've got this block code. Here we go iterating over it and pulling all the entities out. And so what I could do is just say, well, all right, if we start with the first one, like so, and we do a while loop over it, then what I can do is say, well, okay, we're gonna snap a copy of whatever the next block is, right? Well, I guess we're not threaded here, so I guess I don't even have to do that, to be honest with you. What I can do here is just say, like, all right, block equals block, next block, as we were doing before. Oops. And what I want to do here is, right before I do that, I want to put this block on the free list, right? So I guess I still do need to do this, actually, now I think about it. Because this will probably get overwritten, right? All right. So essentially, you can see why I'm doing that, right? Because this adding the block to the free list will probably overwrite the next pointer, and I won't be able to use it. So when we call add block to free list, all I would have to do to support the way we've got things written currently is do a quick check to see, is the block we're talking about the same, I should say is not the same, as the chunk that we start on. And if it's not, we don't add it to the free list, because, hey, it's just that, that block that's sitting there, right? So that's basically all we're talking about. And so all that would require here is us expanding the notion of world chunks to have, like, first free chunk and a first free block. That's really all that matters. So when we come into this code in NSIM, let's take a look at what that's got to look like. So in this code, what we want to do here, and we can probably make this more efficient by binning things more intelligently, potentially, but really all we want to do is when we come through here, instead of having this concept of change entity location, we're never going to do that anymore. Instead, what we're going to do is just the entity is going to get packed, right? And that packing is going to be the thing that that moves the entity essentially into a new chunk. It's going to find the chunk to pack it into, and it's going to pack it. And like I said, this will lead to probably more hash lookups than we really need it to do. And so we probably will want to do something like in the sim entity, it's in the sim region itself. What we'll probably do is keep the world chunks around as a spatial partition of some kind, probably, I'm just guessing, or something like this. And then when we actually do move entity, we'll see if you exited your boundary, and if you are, we'll update you. And that way we can stream everyone out in those chunks really quickly without having to constantly hit the hash. Because I'm guessing that'll become a problem for us eventually if we have enough entities. Maybe it never does, and if that's true, great. But if it does, then that's where I think that approach, that's where I think we would hit that approach. All right. So here we go with that code. You can see from here where we kind of had the change entity location. What I want to do now is say, well, okay, I don't care about any of this stuff. At the very end, what I want to do is pack the entity down. So what I want to do here is call something like pack entity into chunk, right? I probably should just say into world. And that will be the call that actually goes and finds what chunk it should be in and puts it in there. As opposed to there might be an actual pack entity into chunk call, which is once you have the chunk, then it packs it in there, right? And that would be the one we'd call in an accelerated case where we knew which chunk we were talking about a priori. So again, that's probably going to take the world. That's true. It's not going to have to dereference the entity storage. It is going to need that stored entity, which that's the actual entity that we kept. Wait, is that true? No. So we don't want any of this stored stuff anymore at all, right? What is that doing? Stored sim. We don't want this. No, 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 no. I mean, we can keep these assertions, I guess. Entity flag simming. I don't think we need any of that anymore. Since an entity now can only be edited by pulling it into the database, the flag simming on an entity is completely redundant. You can never have an entity by itself be simming. An entity becomes simmable when its whole chunk gets moved in. So if we were ever going to flag something, it wouldn't be an entity, because you know if you can look at the entity struct at all, it's being simulated. Because otherwise it's packed and you can't see anything, right? So we would only need to set that if we were setting that on world things. So this is just gone, right? This is not a thing anymore at all. So that's good. Goodbye. So these are all going to be on the entities themselves, right? And that stored concept just goes away. So anywhere that we were seeing stored before, don't need to do that anymore. So what we're actually going to pack here is the entity. We can see the is set non-spatial stuff. Again, that non-spatial stuff, I don't know that we ever want anymore, really. I think we're probably always going to want the spatial stuff now, because even if you're non-spatial, you will move around with somebody. Whoever the person is who's carrying you or whose property you belong to, you will be with them and you will move with them. And so that is probably not a thing anymore, the non-spatial. So I don't think we'll need that either. And when we do this map into chunk space here, that is this new P. We can leave that for now, but we probably don't really need to do that manually, because that could probably be something that is done in this pack entity into world, right? So if that makes sense. Map into chunk space. There we go. So that's really what that is about. And once I know that that's happening, right? Now that I have that, that's a complete streaming system, right, from start to finish. You can see it here. And so what I really need now is I just need some way of calling that externally here. And I think we've pretty much set ourselves up to do exactly that. So when we call pack entity into chunk here, which is a bad name for it. Oh, wait, no. This is fine. This is exactly what I wanted. That was some placeholder for just when we were, when we were just sort of sketching that in. So what I want to do here is I want to call this, right? I want to call pack entity into world. And so the way I can do that is this world position P, right, is sitting there on the entity low, which we are still actually tracking for no apparent reason. I think what we want to do is collapse that down, because again, we don't really need the low entity thing anymore, and we don't even really need to, we don't need to distinguish between any of these things. So what I can do is I can stop having that concept of the low entity, where was that, in sim region? No. So it's in world mode. So in low entity, we were keeping this. I'm just going to, for now, grab that out, and I'm going to put that into the actual entity struct itself in preparation for getting rid of that entirely. So this is going to be called, like, chunk P or something. And we're just moving everything over in here, and then we're going to collapse this down. So that's kind of the plan, right? So this is going to look like that now. And that means that when we do pack entity into chunk, we should be able to just do something like this, where when we call that, we pass, well, and I guess we don't even have to worry about that. We can just pass whatever the entity low sim is there, right? So you just pass the sim entity, and that can get the P out of it because the P is right there, right? And that's what I want. So this is going to be called pack entity into world because that's the one that packs into the world. And similarly, inside sim region now, what I want to do is make that symmetric. So instead of passing the new P here, I don't actually want to pass the new P. And furthermore, I don't need to pass the world arena. It can get it itself, obviously. So what I want to do here is I want to take this map into chunk space thing, and if I'll take that operation and do it here. Excuse me. So I'll take that chunk P and I'll generate it by doing the mapping back, right? So that's what we're doing there. Okay. Now, and eventually all this stuff can continue to go away. Like I said, this stuff is all like we're going to be able to sort of clean and clean and clean and clean, I think, and then we'll be good to go. All right, so. And you know, I'll probably loft that P out again in a second here, but that's a separate issue. So we don't care about any of this stuff anymore. Change any location, really not relevant in any way and does not matter to us at all anymore. So this is just gone and goodbye, right? Then we come up here and we say get SimSpace P, right? Anyone who was looking for that before can get it if you want. You can just do reference the sim off of the stored entity if you want to, but you shouldn't have to really even do that anymore because pretty soon that won't be a thing. Anyway, what is the complaint here? World position. Oh, sorry, I meant Chuck P, not Chuck P. That sounds like some kind of a sneaker. All right, so remove world chunk is something we need to implement. Add blocked previous, add chunked previous, both are as well. Let's take a look at this here. Entity storage index. This is the thing that we had before about tracking values, obviously. Those are going to get cleaned up as well, too, in a separate pass, but I'm not going to do too much with those at the moment. What did I do here? So this is also a value. There we go. Here is the stored value. We don't want that anymore, so what we really want is just the entity chunk P here, which we've already computed, so that's fine. And the same thing is true of this, right? So that's all good. And when we do pack entity into world, like I said, you know, I think I will, for now, continue to pass that through. And the reason for that is because eventually we can get rid of it all together, and eventually we can just make this be something that gets passed. And in fact, I guess, well, you know, no time like the present. So here's our world. Let's see here. World.h. Here is our world position. So we'll just go ahead and generate that, and I'll pass that through here. And so that when we call pack entity to world, you pass that chunk P, and there you go. And I think, and like I said, I'm just going to take a flying leap at it here. I think I can actually get rid of that then entirely. And the reason that I think that is because inside world mode, if I just changed from when I do begin low entity, if I just moved the world position P down to end entity, right, then I could just pass it here for free and I wouldn't have to store it anywhere. So it wouldn't have to live here. We know the sim doesn't need it, so creation time shouldn't need it either. So let's just make that happen, right? If that makes sense. So we'll get rid of these world positions on creation and pass them on end. And I'm just going to go ahead and see if that works, right? Meow, 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 meow. So here in begin grounded entity, we're passing the P. So really, again, like I said, this should be really straightforward. All I have to do is move it from the begin to the end. Same thing here, right? I just move it from the begin to the end. Keep on going. Here it is. Same exact pattern. So I say that's where I want it to be placed. Right, and I'm just sort of saying, like, place the entity here. Let's see, there's another begin. Get that going. And these are both placed at the same place, so I actually can just do both of them. Goodbye. And let's see here. Code modification. Someday, if Alan Webster does like actually complete his code intelligence editing thing, as he suggested. I wonder if this is the kind of editor, if this is the kind of thing that ForEd will do automatically, which would be kind of ridiculously awesome if it was. I haven't thought it through, if that's something it could have done. Like, hey, I had this pair of things and I wanted to move a parameter from one to the other. It's within the realm of possibility, right? I mean, you could see the editor going like, oh yeah, okay. I'll do that for you. No problem. So I don't know. I guess only Alan can tell us. What does this key do? Oh, that's a key that deletes my buffers. I forgot that's 0. Oh, I have my num lock on. That's why. All right. Well, I don't want that on. So I'm going to reboot. I'm going to reboot. Hold on a second. Sorry, 0 is my key for kill buffer. And I had numlock on. Yeah, I'm not used to even having a numeric keypad, but all my other keyboards now don't have that on there anymore, so. Anyway, so that's, I think, it for the structural changes there. And what we can do now if we wanted to, and we might as well, because like I said, we're just going nuts here. We're just having a little party, a little pizzarty, as they would say, you know, on the streets. So basically what I want to do is just get rid of the that whole double notion, because now we know we never need low entity. So we only have sim entity, right? And so what I can do here is I can just replace anywhere that we were using low entity, I can replace it with just entity, right? If that makes sense. Low entity, entity. Oops. What did I do? I've done something horribly wrong. I don't know what. Low entity with entity. Okay. Yes, 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 yes. These are all yes. Okay. So if I replace entity with low entity, and then I go into simregion.h, I should now be able to say, all right, instead of a sim entity, there's just an entity, and now we only have one entity type, and we still have all the benefits of having two entity types, but we don't actually have to deal with it, right? Which is great. It's double plus awesome in a special awesome sauce with awesome on top. All right. There's just a lot of things called sim entity. As it turns out, sim entity, oh, that's not good. Sim entity, entity. Love that scroll. One more time. Sim entity, entity. All right. So now we've got some low entities here, and I'm just going to take low entity and change that to entity as well. So there it goes. Right. And what else we got? So we've got this kind of stored sim thing here, and stored sim is no longer necessary. So really, those can all be changed. I guess if there's anywhere that has the pattern of stored sim, that can be changed to just stored now, which was not very many. All right. So that still wants to be arrow. That just needs to be that, right? Let's see. So source. Let's see. Start entity equals source. What is source? What was that again? Oh, right. So I've just got to do a star source. Source is just a pointer to the entity that's coming from. And this is just going to be all. Yeah, this is definitely the sort of thing that wait, no, that's fine. This is definitely the sort of thing that 4Coder could do eventually, I think, based on what Alan was talking about anyway. So let's see. Remove world chunk, not a thing. Low. Let's keep going. Entity overlaps rectangle. Low collision. Low storage index, and let's see, keep on going, no, don't care. So here I guess we can probably do this where we have entity low arrow sim dot, it can just be entity low arrow, right? And that's probably just going to be true basically everywhere that was happening. Why did that not... I don't know why that didn't... It didn't seem to get them all, though. Am I wrong about that? There we go. Maybe I did it wrong. Entity low. Oh, it's because some of them were entity low. Now I see what it was. All right. Well, anyway, point being. All right. So SimEntity. So this I can just replace as well. I think SimEntity with entity is now good. And we're almost there. Let's see. Entity sim for add wall. That's just going to be an add flags call. Let's see, same thing here. Let's take a look for add flags. And I think those can all be done the same way. Yeah. Yep. And almost there. Okay. So now that all that's done, I think we're basically at the point where all of the structural changes have occurred. And so really all we have to do is implement those couple of functions that we don't have yet. And those are on the world, right? So the way I want to do that, and I'm trying to look here to see, change entity location raw, like I just don't even think we need any of this stuff anymore, right? That's just does not matter. Pulling the thing out of the chunk does none of this. All of this janky code can just go away, like goodbye. Not relevant. Doesn't matter. Not important, right? Because no one's going to call it. So all we have to do now is we just have to pull it out of the hash completely, and then put it back in. So I'm going to start with the easy case first. The easy case is pack entity into world. That's very simple because we already have get world chunk, which does exactly what we want in this case. It returns to us specifically the world chunk that we would write this thing into, right? And that's exactly what we need. So what I'm going to do is I'm going to start with pack entity into world, internal void pack entity into world. That takes, of course, the world, and it takes the entity, and it takes the location. Right? And then what we're going to do is we're going to get that world chunk out, and we're going to get that world chunk out in a way that tells that underlying routine, hey, by the way, I would like you to, I would like you to create a world chunk in this location if there isn't one already, right? So I'm going to give it the arena pointer here, like so. So I'm going to say, all right, let's have get world chunk operate and give us back a world chunk we know we can pack this thing into. So then the only thing that I need to do is figure out, will it fit in the current place in the chunk or won't it? And the way that I can do that is say, well, right now our pack function is completely neutered. It's just a copy, right? We haven't gotten to the point where we actually do the logic of compacting something down to only the part that's necessary, right? So instead, what we're going to do here is we're just going to do a copy, but that means that we know the total size we need to pack, right? And the total pack size is just whatever the entity size is. So if the entity is however big, that's how much room we need. So we need to see if the chunk, and you remember how this is stored here, right? If the chunk entity data size is at a point where we could add to it and not overflow. So if the entity data size plus our pack size is less than or equal to however big the excuse me, however big the entity data is, right? That's all we need to know. right? So we can come in here and say, all right, that's our pack size. We can see if it's less or equal to, that means we can pack it, right? Now what we want to know actually though, because we always try to succeed in packing, we actually want to know if we exceeded, right? And if we exceeded, we need to make a new chunk, okay? So in pack entity into world, we would need to do a push struct, right, of a world chunk in here. Now, since we know we're going to have a free list, what I could say is, well, okay, if that's the case, I'm sorry, the block, not a world chunk. I mean a world block. What I could say is, okay, world entity block, new block. I'm going to first dequeue off of the free list, right? So I'll say the new block equals whatever the world's first free block is. Now I've got one if it's there. If new block actually worked, then I will say the first free block becomes the next block. Otherwise, I'll do a push struct to get myself a new one. So the world's, oops. You know what I could do that's actually a lot smarter than that? Now that I think about it, I could just do if not world first free block. World first free block equals push struct. That's a little bit better, because then this is just that. Right? It's a better way of writing that code. In fact, I don't know, do I normally write it that way? I feel like that's better than the way that I normally write it. I probably should be writing it this way. Am I missing something here? Oops, arena. So if you look, it's like, if we don't have a free block, we put one on there, right? And otherwise we, right? Otherwise we grab it. Or I shouldn't say otherwise. Then we always grab it. That seems right to me. Probably. Anyway, there you go. So we dequeue one here, and then we need to do the initialize. I don't remember what it's called here. It's like clear world entity block. So we want to do a clear world entity block on this new block because it just has garbage, whatever was in there when we threw it away before, right? So we want to clear that block, and then we want to pack into the block, right? So this is what we do if we need more space. If we don't need more space, then we go ahead and continue. Now what we could do is we can throw an assertion in here. We could say like, hey, after all that funny business, let's at least verify that whatever we were about to do does work now. Like we actually did get the size, the space we needed if we needed space. Okay. So now I need to do my pack. So here's my destination pointer. My destination pointer is just the entity data plus whatever the current size is. So there we go. And I can kind of cast that right to the entity. I can say that's where I'm going to store it. Then what I can do is say, well, the chunk entity data size. I'm going to add however much I packed on there, right? So I've advanced. It's like an arena. I just kind of push onto it, right? I did that push, and now I'm done. All I need to do is my actual copy, so I can do my copy because we're not actually packing. Normally this would be the step where I actually pack, but here instead, because I'm just copying the entity directly in, off you go, right? And we could make this even a little closer to what we're really expecting, something more like this, right? And then it's only here where we actually do the cast, because later we'll just be packing, so it won't be an entity struct. It'll just be parts of the entity struct when we get to that phase of things, right? So that's how packing entity into world would work. And similarly, what we can do in here is, if we want to avoid the lookup, pack entity into chunk, like I was saying, this can be two phases, because you can see where we looked up the chunk and then we packed into the chunk. So what I can do is make this a separate phase here, and that way in the future, if people want to accelerate that process and not hit the hash all the time, they can do that very simply by bypassing it if they already know what the chunk is. And so that's kind of nice. So I'll call pack entity into chunk here, passing the world the same entity, and then instead of the position at, you just pass the chunk. You're like, this is the chunk I wanted to pack to, right? Okay. So this takes the world, the entity, and you know what I might call this source? instead of entity, so that it's clear what's the source and what's the destination of the packing process, right? Because they're both representations of an entity. One's a packed entity, one's an unpacked entity, and so, right, it seems reasonable. All right, so pack entity into world, that's what we need. And it just passes the chunk in, and then once we have the chunk in here, we know that we can execute without having to hit the hash. We just pack onto that first chunk, and if we need to, we can push it down again, right? In fact, you know what I was just realizing, though? That's not quite enough, because I didn't actually do this part. I missed one layer. So what I actually need to do when we get the chunk here, this is actually supposed to be on the block. Oops. So what I actually meant to do was grab the block out here. Oh, okay. So we finally gotten to a place where I care about the pointer. So if I want to constantly do push down, right? If I want to basically fill it up and then move it out, I can't do that unless this is a pointer. I will have to keep a second pointer here that tells me where the last one was, right? So I think that finally answers the question for me of what I actually want to do. And I think the answer is I want first block to be a pointer, right? I think that's clear, right? You want that to look like this, if that makes sense. Because otherwise, what am I going to do? I don't want to chase that pointer every time. I don't want to have to walk it to the end. So it does seem to me that that's just better. Even though it's double dereference, you were going to have to dereference anyway as that thing fills up. I think that's probably what you want. The other thing to do is somehow try to mix this with the hash. And I don't know what I think about that. But you could imagine doing it that way, right? Like what we could do instead is actually just say anything in this bucket that matches the hash. And you walk through and you pull those out. I don't know what I think about that. Doesn't seem great to me, I guess is what I'd say. So I think that is actually the way that I would prefer it, if that makes sense. So what I'll say here is, we're going to pull this block out. We'll take a look at the first block. I haven't got much time left, only about 5 minutes or so. So we'll pull that block out, and then I'll say, hey, if there is no block, right, or I can't fit, right, this thing doesn't actually fit, then I got to do the action, right? Then I got to say, all right, let's grab this block out here. And then what I need to do is I need to push it onto the stack, basically, right? And I could sort of even make this be a little bit more explicit by just using chunk first block and not actually having block as a pointer at all, if I want to, right? I could say, if not, chunk first block, and you know what I could do here, has, right, a bool 32 of has room for, which would take a world entity block and a size, and figure out whether or not it could fit, right? And that would just be this. And the reason that I like that as well is because it's easier to see what's going on, and I can call it the same for the assertion, right? So I can say has room for pack size, and here is my block, chunk first block. And then when we start, we'll always just say, okay, what we're packing into here is always the chunk first block. Okay. So that's good. All right, so let's push forward on that a little bit. So here's the result. The result of this function is going to be if whatever the block you pass me, well, it's the same thing that we were doing before, right? It's the exact same thing. And so all I'm going to do is say, if it has room for is going to be phrased that way, so it has to be less than or equal to, right? And then I'm going to return it. So in here, we're going to say if If there's no first block, or if the first block doesn't have room, then what we're going to do is we're going to pack. And we're going to do that like this. Then what we're going to do is we're going to make a new one. We're going to do that by either getting one out of the arena or grabbing it from the free store, whichever one will actually satisfy us in the case. The arena is like the secondary fallback, right? So then we grab out whatever the first block actually is. We come in here to these sort of pack size things. This I can now replace with the has room for of the block, and I can text with the pack size to verify that that works. Then we go ahead and say if we can pack it into this block. Well, actually, I guess we know we can pack it into this block, so let's find the location and then do the actual pack. And this records the fact that we use that much space. Excuse me. So that's it. And that all seems pretty good. Now, we're going to have to modify our get world chunk a little bit here. Excuse me. Because our get world chunk now has to have this notion that there is a first free block pointer. Now, I don't actually think that's necessary to do pretty much anything other than setting its pointer to 0 on an it in here. I think that's all that actually has to happen. So it's really, really simple, not very much difficulty. Whether we want to now switch it so that the world chunk is, whether we want to now get rid of this pointer, I don't know, right? We may want to, we may not want to. I'm just not sure which we want to do there. It's hard to say. I suspect we'll just leave it as a pointer for now, and we'll see if whether we have performance issues in the future and only change it then, because the pointer is going to be easier to work with. All right, so I think that's everything for pack entity into chunk. Let's take a look. Block equals first free block. Actually, so what I'm doing is chunk first block equals world first free block. There we go. There we go. Okay. The entity here in this case is source, not entity. And so now let's see, initializing, reinterpret cast, add block freeze. Okay, so it looks like mostly now we are in good shape, because now all we have to do is implement the part where we pull the things out, right? And that's, again, not super difficult. Inside world here, we have to have things for adding, we need these two functions basically, right? We need add block to free list, and look at all the pretty colors, and add chunk to free list. So in this case, here's internal void, add block to list, internal void, add chunk to free list. So, so we've got our world. This is honestly an inline, because this is really, really straightforward. So we have our world pointer. And we now have this world entity block that's like some old thing we want to free. And so all we have to do there is say, well, the old next just equals, same thing we do all the time, equals the first free block, and then the world first free block equals the old, right? Same old, same old. Really boring. Like I said, if you've got any metaprogramming in the language you're using, you can trivially, you can metaprogram a free list style allocator. It's so simple, right? You can kind of see how that works. But anyway, so for world chunks, same thing. First free chunk. And the reason you do that is just because it's not like it's hard to type this, but I might make a mistake, right? Like anytime I type that in, I might make a mistake on how the free list works. So that's the reason you metaprogram too. It's like it's only 2 lines of code, so you're certainly not saving any effort, but it's that mistake, it's that error proneness, like, oh, did I mess up the free list, right? That's why you metaprogram those things, so that you can reuse them that way. Anyway, so in remove world chunk, we haven't touched that one yet. This one, where we do world entity block for this first block thing, for this one now we can do this the way that I had said that I wanted to do it before. So instead what I can do now is say, all right, let's do a, let's just dequeue it directly here. And I guess I don't really have to do anything else. That is what it is. I can just make this more straightforward and be done, right? So that's good. All right, so all we need now is a remove world chunk. So hey, you know, I'll go a little over time. We're out of time technically at the moment. We'll go a little over time just so I can type it in. And then that way next week we can start with all of our changes having been made, and then we can just focus on actually like getting everything to work, right? Doing the debugging and that sort of stuff. And that'll be nice. So here we go. Here's my remove world chunk. Now remove world chunk is basically the same code for all intents and purposes as the get world chunk code, right? So this code right here. So what we need to do is we need to just make it work slightly differently. The reason we can't just call it directly, and the reason we're going to have to modify these a little bit, is removing the world chunk requires knowing the in pointer, right? And I'll show you why. So let's say I was to call get world chunk right here, because I want to remove the world chunk. So hey, I know I can reuse this code. I can say, hey, world chunk, chunk equals get world chunk, and I can just pass. I've got all of the exact data that I would have needed, right? It's all here. So that'd work, right? But the problem is now, how do I actually get it out of the hash chain, right? I can't actually get it out of the hash chain because the person who's pointing to it is before it. I don't have a previous pointer. But I would have had the previous pointer if I'd implemented this loop myself. So really all I have to do is say, okay, get world chunk as it stands before, right? Let's grab out this part of the code. And instead, let's actually call get world chunk internal or something. Now I've got that code, and what I'm going to do is I'm going to modify what it returns so that I do have the in pointer, right? So here we go. Let me just show you what I'm talking about. So in here, I'm gonna make this my new get world chunk that everyone on the outside calls. And this is a very standard technique, right? You've got some people flowing into an entrance point, and I'm just pushing the actual internals of that down one layer so I can have two entry points that both use its logic but do different things on the outside. So this is get world chunk, and so now in order to get the chunk, I need to call get world chunk internal, and I'm passing the same parameters sans arena. Right? And the problem is now you can see all of the same issues that occur here. I can do all the work right up into the point where I needed to know what was my in pointer, right? So all I'm going to do is say from now on, instead of returning the actual pointer to the chunk, I'm going to return a pointer to where its pointer would have been, right? So I'm going to say, hey, let's find the person who would have pointed to the correct chunk, which tells you both things you needed to know. So here's my iterator, right, over the chunks, and here's my result. So instead, same exact loop. All I'm going to do now is instead I'm going to use the ampersand for those pointers, and I'm going to look at the dereferenced version, right? That's it. So now it's always using a pointer to the pointer to find it, and then when it returns, it gives it back, right? Actually, that's all we need there. Make sense? So now in here, when we come back, I've got chunk pointer, right? And I can dereference it. And what I can say as well, well, in fact, I can just say result. What I can say is, okay, if result isn't valid, I do all the same things I was doing before, but now I have the actual information that I actually wanted here. I want to know what was in the slot that was my in pointer. What was it, right? And I want to know what was there. So I just dereference what was in that pointer, right? if that makes sense. And I'm trying to think about this. This is slightly different in the way that it worked, in that this adds to the end instead of the beginning now, but I don't think we care, right? In fact, I don't know why we would care. We don't care, right? And similarly, I'm just going to go ahead and put the tail on here. I can just say, well, whatever that was in that slot before, I'm going to make that point to me now. So it's exactly the same thing, because now we have the information to do it. For remove world chunk, same exact thing. I now have a pointer to a pointer. So what I want to do is save what was there as my result, because that's what the person needs to know, right? But now that actual pointer wants to be modified. So I want to then take what was in that slot and I want to leapfrog it over the one I actually grabbed, removing it from the list. Does that make sense? Hopefully it does. Okay. And gotta return my results. So, I know that's a little complicated, and like I said, we're done now, so let's run it and let it crash and burn, because it will. And then we will go and debug tomorrow. Well, I guess this one's probably simple to debug. I always like can't help but debug, right? So, right, that makes perfect sense. I no longer want to ever return 0 in this case, right? I always want to return whatever the world chunk is. So this is really, I always want to return that in pointer because there's always a valid in pointer. There we go. Voila. In fact, I guess this is now not even, right? This is actually this. Oops. This is just saying, hey, while there's a chunk and it's not the chunk we're looking for, indentation. We advance. Do I have the right number of parentheses? No, I don't. All right. So sorry. Now we can let it crash and burn. There we go. That's what we actually wanted to see happen. And hey, that caught a bug. Did that catch a bug? Creation buffer locked. Add player. Yeah, we tried to create 2 entities at the same time, which we don't support. See? Caught a bug. How good is that? How good is that? I could fix that one too while we're at it, I suppose. Add player. Right, because these are 2 begin ground entities things. So, I mean, I feel like I just want to support that kind of, to be honest. So I don't know, like, you know, maybe I want to support creating multiple of these entities at the same time, you know? Could imagine something like this, right? Where I like let you use a couple there on and off you go. You could just do it with temporary memory too. Now that I think about it, why did I even do that? Why did I even do it that way? You could just push it on the transient arena and go. So that's arguably perhaps a little bit stupid just in general. But yeah. Yeah. That's questionable. But I could totally do it this way, right? I can just do something like this. begin low entity just does assert world mode creation buffer index is less than array count world mode creation buffer, and then I just say world mode there. Right? And then in here, when we do end entity, we just go like, okay, the creation buffer gets docked. And we can also assert that once it gets docked, that you are pointing to the correct one. There. Lovely. All right. Okay. So I think, yeah. Okay. So I think in that case, I'm sorry. I'm kind of just obsessing over, like, since I did all that code, I usually like to leave it in a good state. Like I said, the whole have to end in an hour thing, you know, it's always a little bit of a struggle for me because if you're a obsessive programmer, you don't like to leave something. You want to like finish it. It's just how it is. You can't. I don't know. That's just life. So anyway, what I was going to say is that's an easy one too, right? It's like we occasionally don't remove any chunks, so I didn't bother to check to see if there were any chunks in there. So in remove world chunk, when we get back our chunk pointer, what we want to do is say, hey, if we're not going to remove anything, then don't try to leapfrog over something that's not there, right? So that's easy as well. All right, so we're good. Now we're on a thing where we've got to actually we have to actually figure out if they're running heroes and all that kind of stuff, and have the camera there. We got a bunch of init stuff to do, but we're running now, so we can at least leave it in an okay spot, and so that's good. So I'll go ahead to the Q&A, and while I'm waiting for the Q&A to queue and A itself up, I will also. Why am I CMuratori 2? Can we talk about why it insists on logging me in as CMuratori 2? I don't know how to change my name. Why am I CMuratori 2? There we go. Okay. Okay, so what I was going to say is while I'm waiting for some cues, I am going to mention what happened with that list situation. So here is how this worked, okay? Well, let me show you exactly what happened. So here's the world, right? And it's got a hash table in it, right? So in here, inside it, if we were to talk about this one portion here, I'm going to blow that out. Here's the hash. And the hash is a series of pointers. So each one of these is a pointer, right? So in one of these hash entries, there's just a pointer, and it points out to a chunk. So here's a chunk. And inside this chunk, we have another pointer to a block. Right? Now, we don't care about this part for this, so I'm just going to leave it out. In addition to that, we also chain these so the chunks keep going. Okay? So, what I had was a function that does the hash lookup and finds the right chunk in the chain, right? Because in the hash bucket, there may be multiple chunks that are not the same, that are different, right, places in the world, and we got to find the match. So we have a function that finds the hash bucket, and then it looks for the right match in the external chained hash, right? Now, what I had was a problem where I was returning the actual pointer to the chunk. So let's say this was the matching chunk. I found it, right? Well, that's just great for anyone who wants to use that chunk. But if what the person wants to do is actually remove the chunk, they can't because the piece of information they need to edit is right here. And they have no pointer that goes back to it. So instead what I did is I said, okay, instead of giving them back a pointer to the chunk, I'll give them back a pointer to the pointer of the chunk. So what I did is I start the loop pointing at this location. So now anyone who wants to know if the iteration stopped there, so I checked this chunk because, right, I look at what's pointed to and what that's pointing to, and I look at that chunk, and if that chunk matches, then this is what I return, is this pointer to here. So now if the person wants to edit it, they have that position. If I need to advance this, so this is not the chunk, I need to look at the next one, I make my pointer point here. So when I return this chunk, I actually return this location of this pointer so that I can both get to the chunk by dereferencing it or edit what's pointing there by overwriting it, right? So that's why the pointer to the pointer. Hopefully that makes sense. Novin, how are you finding Milton? I didn't catch the start of the stream, sorry. So basically, I think the only problem with Milton is currently the brush tracking. It's just not good enough yet. Like I think it needs like some tapering at the end on the pressure. It needs like a little pressure taper, just a bit maybe more than it is. And it needs a higher sampling rate or less lag. It's just basically the brush handling is the only thing that's a problem. Other than that, it's way better, actually, because the interface gets out of my way trivially, which is nice. Oh, that's interesting. That's interesting. Tab, when the interface comes back, switches to tabbing between those two. I feel like that's probably a bug. I should have read and report that. Anyway, the interface gets out of my way, which I like, and it handles auto-saving, so I never have to save it and wait that big, long, spinny cursor thing. So I would say if Sergio can fix the brush handling, I would say it's a straight win across the board. And it's basically like just straight up better than Mischief, period. As for now, it's a bit of a trade-off because the brush handling is not as good. That's where I'm at so far. Pulsix, how do you pronounce your name? Casey Muratori is how I pronounce my name. Elvin, is the sparsity system the same as mix-ins that you mentioned before? If not, are we ever going to use or talk about mix-ins? I'm really curious as to what they are. Yes, so mix-ins is not a technique. It's a ability, if you will. Like the concept of a mix-in is just what it kind of sounds like. It's like I want to be able to combine a bunch of these things together arbitrarily at runtime, right? It's exactly what C++ can't do, right? C++ at runtime can't say I want this and this to be combined or any of that sort of stuff. Now, you could say that multiple inheritance in C++, right, is compile time mix-in. Which is basically saying at compile time I can compose multiple things together using multiple inheritance C++. C++ has no runtime mix-in ability. That's why we implemented it ourselves. Using the sparse entity system is my way that I'm going to do that. There's other ways, right? Like I went over those when I talked about the sparse entity system. I said, hey, here is, you know, how here is, like, you could keep a list of properties and you add and remove them at runtime, that sort of thing. If that makes sense. Do friend classes count as mixins? No. First of all, a mixin, to be clear, there's two things, right? There's compile time and runtime. Friend classes and unions obviously are compile time, so they don't have anything to do with a runtime mixin, which is what we actually want. We need runtime mixin. Like, we need to be able to do runtime arbitrary combinations of types, right? So no features of C++ help you. They are all compile time, so they can't do this, right? So you have to implement it yourself using, things that are in C++. You need to implement it using those. You can't use some feature of the language, if that makes sense. Paul 6, couldn't you avoid having to compress the entities if you use some unions in the entity? No. And the reason for that is that as soon as you use unions, you lose the ability to mix in the two things being unioned, right? So whatever I made a union out of, I now can't have both of those things happening at once on this entity, which may be, in a real rare case, we might do that when we know there's literally no way these two things can happen, right? But that's almost never what we want. In this game, we want to always have every possible combination is allowed. Elvin, how are you finding 4Coder so far? Any features you find missing? Is it worth getting into coming from Emacs? Yeah, I like it way better than Emacs. There's a few Emacs features that aren't in there yet. But they're coming. And also, some of them are just because I haven't gone and made my 4Coder custom have them yet. So some of them are waiting on me, not Alan. But basically, like, the indentation is a little buggy. That's the biggest problem right now. The biggest problems, no macros, indentation's a little buggy, and autocomplete doesn't use nearby to pick the matches in that order. That's mostly all I'm missing. Everything else I could do in 4Coder custom myself. And for modal, which is the way I'm editing now, it's way better than Emacs, because Emacs was super buggy in modal. Like, just crazy buggy. Which is why I switched in the first place, because it's, it's pretty early in development for 4Coder, so I may not have switched this early, but Emacs was killing me. What do you think of the other more data-oriented entity system implementations online, like ANAX, Entity X, etc.? I don't know. I've never looked at them. It would probably be something I can't just search and read quickly, I'm guessing. But let's see. I mean, the fact that, like, the number of semicolons per line appears to approach 8 fairly frequently means there's no way I would ever even touch this code with a 12-foot pole, but that doesn't mean it's necessarily designed poorly or anything. It means it just uses the kinds of stuff that I find very superfluous and too much typing necessarily, but who knows? Maybe it's designed well. I'd have to actually go look at the design and see, right? All right, I'm going to wrap it up. Let's see here. Where is it? There we go. Thank you, everybody, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always do so. If you pre-order the game on handmadehero.org, it comes with the source code so you can follow along. We also have a forum site you can go to if you want to ask questions, a Patreon page if you want to support the video series, a schedule about the tweets to schedule you, and a episode guide if you're trying to catch up on old episodes. that is it for today. I will be back here next week. Check the schedule bot if you want to know when. Until then, have fun programming, and I will see you on the internet. Take it easy, everyone.